Okay, let's clean things up a little bit here because we probably won't need the failure because that's the same thing as error. Besides, it's too harsh. Let's get rid of failure altogether. And also I noticed because I copied and paste, this is a good lesson. For loading here, I said idle. So this should be loading. Yes. Okay, of course, that should change some of our results here. Let's run one more time. Okay, see, went straight to loading and then success and error. Okay, this is the correct thing that should work. This is the correct order as well. So as we see here, using this enum class, it's really powerful in so many ways because we're able to create some sort of state, create this state handling, and it works fine. But what if you wanted to, say, print unique success messages depending on the data fetched? That means if it's success, we want to be able to pass along more information to the success if we need to make this more flexible. Say if the message we are receiving from the network is X, we want to pass that X and more information about that X or about that data that we're receiving. Same goes to error, idle, and loading, and so forth. The way things are right now with enum classes, in order for us to be able to pass metadata or data into our enums here, we would have to have something like this, a structure like this. We can say val data, and then say we want a string type or int or whatever we want. But as you see here, we have a compilation error because this enum class, it won't allow us to do so. That's one limitation. So we are limited to only pass these one types that are specific, like this: success, error, idle, and loading. That's the limit we have. We can't attach anything to any of these types like this. But we want to be able to do something like this because that will make our state more flexible and we can add more data for each one of these types, each one of these stages, each one of these states. So how do we get that result? How are we able to accomplish that? Well, to solve this problem, we can inherit from an abstract class. What is this thing called abstract class? We'll get to that. So an abstract class, as the name implies, is more of an abstraction of what something is supposed to be. For instance, if I say something like this, this is just a conversation. If I say, here is a chair. Conceptually, you understand what a chair is. You can grasp that. And it's something that exists in the real world, right? Now, if I say again a triangle, okay, you understand? Yes, a triangle has three sides. There we go. You understand that. You can grasp that. There are forms of a triangle that you can go by or create, and you can hold it, a triangle. Okay, very good. What if I say shape? When I talk about shape, you conceptually understand what a shape is. A triangle is a shape, but a shape is not a triangle. That means a shape is very abstract. A shape, we can't really touch shape as it is. We can touch a triangle, a rectangle, a circle, which is a form of a shape. But a shape itself, it's not really anything that we can grasp, that we can hold. It's just an abstract idea. Does that make sense? So an abstract class really represents those abstract ideas. In this case, it's a class whose functionality has not yet been implemented. A shape in this case would be a class whose functionality has not yet been implemented. We only implemented shape if we have a triangle, rectangle, circle, and so forth. So this abstract class can be used to create specific objects that conform to its protocol, to its rules. So we're going to use an abstract class for state management instead of using the enum class here because it will give us that flexibility that we need. So let's go ahead. I'm going to go ahead and comment this out. And right away, I'm going to say abstract. There we go. And I'm going to say class. And I'm going to say result. Okay. And that's it. We don't have to do anything. And then for each one of these types we had inside of our enum here, I'm going to create a data class for each one of those. Remember, a data class allows us to just hold data, which is exactly what we want at this point. I'm going to say data class, and I'm going to say success. And now, look at this. Now I can actually pass something like this. Val data fetched attached to the success data class. Remember, this is the constructor, primary constructor, which means these, whatever we're passing right now here, is going to be what? Well, that's the property of this class. And I'm going to say the type is going to be a string, and I want this to be nullable. That's why I'm going to attach to it an exclamation point. The beauty here is that, of course, we have this data class, but the whole idea is that what we want to be able to do to get that flexibility we want to make it so that this one, the success data, will conform to the result abstract class to implement it. So I'm going to say, in this case, inherits, right? And then I'm going to say result like this. And of course, we're going to have to put inside it, we have to put those parentheses there. What we're saying here is that success now can now emit a unique string, which is this data fetched here. Could be anything. You could call message, data, doesn't matter. And we can do the same thing for others. I'm going to copy, paste, in success. This is going to be error. In this case here, I'm going to just say error. It's fine. And actually, let's make it an exception like this. And it's going to be an exception type, Kotlin type, like that. Okay. And of course, we're still going to extend result. So again, we're saying here, now, because it's a data class error, we're passing this exception, which means we can emit unique exception values as we go through the states. Now, if we don't want to emit anything, really, meaning we don't want to pass any data when we are at that state, we can just use object like this to say, this is not going to emit anything. I'm going to say, for instance, not loading, right? This will just not do much, really, but we still are going to adhere to our abstract class, conform to result abstract class there. I can do the same thing with another one here, for instance, loading, and just say result like this. Now, when we have this created at this point, obviously we're not using it. We're not using any of these data classes or object classes there. We have a problem here. So it makes sense because we're no longer using the enum. So we have to change a few things. So in our repository here for load state, first of all, instead of idle, I'm just going to use what we have, not loading, right? And then this stays the same. Now for load state, I'm just going to go ahead and say loading, right? That's all we need. We're not going to emit really anything. And then that stays the same. Now finished here for success, I'm going to just say success. Ah, this is the beauty. Success, now I can pass data. Look at this. For data fetched, I can emit something. In this case, I'm going to say data fetched. Now, because these two have the same name, I can just omit one of them. So I can just get rid of this and pass just data fetched like that. Look at this. Now I'm emitting messages through my state machine system here. Ah, now when there's an error, what I can do, I can just say error. I think we created that. And then in this case, I'm going to pass an exception. And just going to pass exception. Oh, this has to be Kotlin exception. Look, there's difference here. One Kotlin exception. And then we can pass a message here, say exception. And everything else stays the same. Now we'll also have to go change, of course, the results here. Now, because we're using data classes, we're using abstract. Now we can change this. In fact, if you say Alt Option Enter, first of all, it's going to ask us to use the else branch because it's necessary because we're using a class per se now. First of all, let's go ahead and change all of this. Let's get rid of all of this altogether. And now I'm going to use is, okay, error. If there's an error, let's make sure we're getting our error, not anybody else, right? If there's an error, then I am going to say, we can put inside of curly braces there, print ln. I'm going to say load result in this case, the exception, I want to string. So we're going to take the exception. So we're going to take the emitted value, which is an exception, and just make it to string so we can see. In other case, if is success, look at that. In this case, I'm going to print ln. I'm going to say load, actually say result. Look at this, dot data fetched. I'm invoking those properties, all right, emitted values. And then I'm going to just go ahead and make sure that if something happens, we can pass this message that says, ensure you start the fetch function first, something like this. And then is loading. If that's the case, then print ln. In this case, we don't emit anything really because we just passed object. In this case, for loading, remember, we are not emitting anything. It's just object there. That's fine. But we can still pass a message here that says loading. In other case, if it's not loading, we have some issues, then I can say something like print ln idle, like this. Now, we must add an else here. It's expected because we've changed the types. The moment we have data classes and abstract classes involved, or any class for that matter, then this has to change, which means return when will require us to pass an else. In this case, I'm going to say print a message that says not available, something like this. Right, so let's go ahead and get rid of some of these issues there. Just imports that are not welcome. All right, so let's go ahead and run this real quick. Aha, and there we go. It says loading data Java lang exception. So there we go. So loading, we got data, and we called exception. Now the important thing here is that we're able to emit messages. This is very powerful because this data here can be anything that we set up, and we can omit information as the state machine goes through its process. It's really important concept, especially when we go and start actually creating applications that need this system together so that we can actually have data. We know what data we're getting. We can work with that data. We can wrap that data around that state, and we can use it whenever we need to. It may seem kind of like overkill, I understand, but believe me, this is a very important concept, and you need to master this concept. You have to understand what's going on. You have to understand how to use state in this case. Okay. Now, you notice that we are doing really well at this point, but as you see here, we lost something that's really important, which is the restricted set of types of enums was really great, right? That was essential because we didn't have to pass this else here. Now, with creating, in this case, our abstract class result here, and we are implementing result, that abstract class, now the compiler is going to complain if we don't add this else here, okay? This else branch. The reason why is because the compiler cannot tell whether the when statement is exhaustive or not, meaning that it doesn't know if this is the end, because we could have more than just these states, right? So that's one thing we lost when we got rid of enum, because enums is exhaustive. It knows exactly these are the types that we are passing, and that's all. But when we start creating abstract classes like we did here, creating our state machine where we are able to pass data along, right, emit data, then that we lose that because the compiler assumes that you can have many other types, hundreds and hundreds of types, of course, if you need to here. So that's why we have to pass an else here. Now there's a way to fix this shortcoming. It's a small, but it's very important, and we're going to learn about that in the next video.